Okay. Good afternoon, everyone. Today our topic is synthetic point cloud generation for class segmentation applications, presented by Maria and Sandeep. We both are working in Agapaki's digital twin lab, and we both are in the first year of my master's in doing thesis. My major work includes the instant segmentation of industrial point clouds using AI, and Maria handles the data generation. So presentation structure is going to go like this. First, we'll discuss what's the problem significance, what's digital twin, different types of laser scanners available, research methodologies we have used, and also conclusion and future work. So as we can see on the image that there has been a disaster in the oil and gas industry, and this is a very serious issue over worldwide. So if we look in the statistics, we can see that there has been a global infrastructure fall by 0.35 to 0.37 trillion dollars per year, and 72% of the existing facilities are more than 20 years old. So it is very difficult to replace these existing sites with the new sites, and there has been more than 10,000 failures resulting in $6 billion financial losses, and this has resulted in unplanned shutdowns of all the industries, which has costed $50 billion per year. So if we look into statistics, it's a quite huge loss. So we have to prevent such oil and gas industries. So we have found a solution that this can be helpful to prevent such losses. So digital twins help us to help us monitor and have maintenance of the oil and gas industry. It has the potential to resolve all these problems we have discussed, but the problem is the cost outweighs their benefits. Also, the BIM modeling is very time consuming and it's very labor intensive. So we have found AI-based solutions that will be very less labor intensive and it will be very efficient. So a digital twin is a virtual representation of a physical object or is a geometrically accurate representation of an object. This has been around since 1960s, and NASA was the first company to come up with this term. Today, there are many companies who are actually working on the digital twin technologies, and recently Siemens and NVIDIA has signed up for making a digital twin version. So if we see that there are many benefits of digital twins, like it reduces operational risk, it assists in predictive maintenance, it helps in better financial decision making, it enables real-time monitoring, and it improves production time. And if we look in the statistics, yes, it is a quite huge billion-dollar industry, and it has allowed the builders to save around 15 to 25% in infrastructure market by 2025, and it will help us to generate $8.9 billion in revenue in 2022, and it is projected to reach up till 96.5 billion. So if we see that it is a very important and it's a very huge scope it has. So we're going to discuss about the problems or the solutions we came up. So this was the design made by my professor Agapaki. So she used a laser scanner in the area, in the oil and gas industry. She scanned all the objects and created the point clouds. Once the point clouds was ready, it was used for the further segmentation. So first we did was the class segmentation and then the instance segmentation. So class segmentation works in upper level, so it classifies objects like the straight pipes or round pipes or the walls. But if we go more in depth, that is what is called as instance segmentation. It identifies each kind of objects within a class, like round, straight. This is another example of the semantic and instance segmentation. If we see, there's a two-dimensional input image, and semantic segmentation helps us to identify the roads, the background, trees, cars, but in instance segmentation, it helps us to identify different types of cars or objects in the image. And this merge semantic and instance is called as the panoptic segmentation, and this is what we aim. We want to make a panoptic segmentation of the industrial point clouds data. So the data set looks like this. We have the point clouds of this 7 kind of different objects, and if we see in the percentage, it indicates the amount of objects present in the area, and the R's mentioned is the time taken to manually model these objects. So we can see that if we manually model all these objects in Autodesk or Revit, it will take so much time to model all these objects. So we have to find a way, a easier way, a quicker way to generate this data and to put it in AI model. So this was the challenges we faced. So it was the most labor intensive process to create the data. It's very time consuming. The chances of errors are very high as it is human made, and the real world data is very limited. Also, the statistics says that the cost of bad data amount to $1.8 trillion losses in 2020 in construction industry. So This is a very huge and serious problem. We need a good, efficient data, and the process of generating data has to be very quick so that we can use these point clouds in AI modeling and for further segmentation, and we can solve all the problems as we discussed in the past. So my colleague Maria, she has come up with some research techniques that will help to generate the synthetic point clouds data, and she will continue further.
So for the research methodology, we are kind of doing the first steps. We are doing the literature review for different virtual laser scanners because we are working on synthetic data, virtual data. And for step 2, it's the review of the existing virtual laser scanners, and then we just pick one to kind of test the data. Okay. First, we have a BIR-Scan 3D that is a terrestrial laser simulation designed as an educational tool for independent users for university purposes. Yet, the results have not been evaluated or its functionality, but the overall geometry works. The second one is Helios, that it's a library that has a core package and various models that perform different tasks. The platform is mounted with various parameters that can be adjusted to represent specific classes, such as helicopter, multicopter, simple linear platform without any movement code. The scene component contains a data structure that holds the scene geometries and materials. A scene in Helios is defined as a triangle mesh that holds a reference and a material definition, able to describe physical properties of the scanned surfaces. For the third one, we have Helios++, that it's the new version of Helios. Helios++ compared to Helios presents an 83% reduction in run times and 94 less memory requirements. It simulates a beam divergence using a subsample strategy, and it creates a full waveform output as the basis for the analysis. Helios++ ensures that the angular distance between adjacent subrates is approximately constant, allowing the combination of input data. That's what we need, real data and then synthetic data all together. Then this classifies kind of the scan into two main sections, transmissive and not transmissive. The transmissive one allows us to see through the object. So this will allow the study of X, Y, and Z all together. And then the not transmissive one, it's like a slower process where you get just object by object of the scene. The last one, it's Blender, which is no part of our this is not the one that we pick. This one does not allow real-time simulation, but it casts several rates simultaneously. And the simulation accuracy increases by modifying the sensor code if features are not yet available for the ray tracing required precision. Although the functionality is limited because of the computational demand to simulate a large amount of laser rays, the performance suffers on the way due to this high computational demand. The one that we picked was Helios++, and I will talk a little bit about the process of getting this into Python bindings. And first, the requirement of Helios++ is to have an XML file that you can convert as a .xml. The problem is that you just have to do it on Helios++. If you have another platform to convert the file, it won't work because Helios++ have a set of legs that you have to predetermine the values or set the values before doing the survey for the laser scan. After that, you get the output as segmented point clouds coming from the OBJ at the XML file altogether. A little bit about the survey of Helios++. We have the legs, as I mentioned before. It's kind of like you have to set the terrain, and then you have to use the virtual laser, setting all the X, Y, and Z parameters, value by value, depending on the object and the image. Then you have the scanner, that it's just a beam divergence as normal scanners. You have the platform, which you have TLS, MLS, and ALS, and then you have the scenes that it's like your input and output. For our future research, we want to work on synthetic point cloud generation. These have to come from the big models that we are manually doing. That's what we want to work on it to stop that, to help with the maintenance of industrial facilities, and then work together with CLOI-NET segmentation, as Sandeep mentioned. This is one of the sample scenes coming from Helios++. We have different elbows as the input, and then synthetically we generated this laser scan kind of for the elbows. This is the side view of the scene for just general figures, and it came as we wish to have results. The work done so far, we have a literature review on BIM, IFC, object files, and XML, and the possibilities to convert 3D models to synthetic point clouds. We prepare and convert data to XML for Helios++. We did research about the various virtual laser scanners in which we pick Helios++, and then we improve data conversion to find better results. On our future work, we want to change the parameters to optimize results in Helios++. We want to find a faster way to convert the OBJ file to XML on Helios because it's pretty time consuming, even though that we get good results. And then we want to add and modify data for the point clouds. As a conclusion, we can say that this is the first benchmark for instant segmentation of industrial point clouds with synthetic point clouds in our end. The IFC files need to be parsed to individual objects so they can be used in Helios++. This is a limitation that we have right now. And then we have that Helios++ minimizes the needs for data conversion that lead to a more efficient generation of virtual scan point clouds. Thank you.